guys. So maybe internet saya slow sikit lah. Alright. So chapter 4, multiple integrals. Alright. So subtopic 4.1, area in polar coordinates. Okay. So area in polar coordinates. For subtopic 4.1, we are actually doing the single integral. Okay, single integration, integral. Which means that only with respect to one variable, single integration. And the formula of area in polar coordinates, we have equals to 1/2 integration from A until B r squared d theta. Okay, r squared d theta. So guys, the angle, okay, theta is the angle starting from A until B, okay, which means that this is the limit. All right. So now let's take a look at exercise 4.1. Okay. So let us do the first question for the rose curve. We have r equals to 4 cos 3 theta. Okay guys, so first of all, we need to sketch the region. Okay, we need to sketch the region. Right now, how many petals do we have here? For this rose curve, how many petals?
3.
Three petals. Okay, good. Very good. We have 3 petals. So as I mentioned earlier, in your final exam, we just cover chapter 3 and chapter 4. Okay. However, what you already learned in chapter 1, especially the graph sketching, will be used again in chapter 4 in order for us to sketch the region. Okay. Maksudnya, apa-apa yang you dah belajar dalam chapter 1 tu, kita akan guna balik dalam chapter 4 secara tak langsung, indirectly. Especially about sketching graph lah. Okay. So secara formalnya, hanya chapter 3 dan chapter 4 saja cover dalam you punya final exam. Tapi still, you kena guna balik what you already learn in chapter 1 tadi tu. Sebab kita ada kena lukis graph. Okay. So, we have rose curve. 3 petals, so straight away sketch the graph. We have this first petal, second petal, and third petal like this. Okay, we have X and Y. Okay, for the rose curve, it's better for you to calculate the area of one petal and then multiply with the numbers of petals. Okay, number of petals. So in this case, the number of petals is 3. Okay, number of petals is 3. Okay, so after we identify the number of petals, next we need to identify the bounded angle. Okay, the bounded angle. Let's say we consider the first petal here. So the bounded angle should be right here. We need to find what is the theta here and here. Okay, what's the values of theta that bound the first petal? Okay, so first step, find the angle. Find the angle. Guys, clear ke? Sebab hujan lebat sangat kat sini. You all boleh dengar ke suara saya ni? Saya kena menjerit sikit.
Boleh.
Hujan sangat lebat. Sorry guys. So find the angle. Alright. This step is just for the rose curve. Only for the rose curve. So find the angle for the rose curve. We need to let r equals to 0. Previously in chapter 1, kalau you nak lukis rose curve, kita let r equals to 4 kan? Dalam case ni, r equals to 4. But in this case, to find the angle, we need to let r equals to 0. Okay, so we have r equals to 4 cos 3 theta. So equals to 0. Cos 3 theta equals to 0. Therefore, 3 theta is arc cos 0. So if you use your calculator, shift cos 0 is equivalent to what? If you use your calculator, shift cos 0 is equals to
Pi over 2.
90 degrees or pi over 2. Yes, very good. 90 degrees or pi over 2. So we have here 90 degrees or pi over 2. So as usual, as in chapter 1, we need to divide by 3 because we just need theta. So it becomes 30 degrees or pi over 6. Okay. Therefore, guys, we already have the values of angle here should be pi over 6. And since this graph is symmetric about x-axis, of course, the lower angle should be the same value with negative sign. Okay, this is negative pi over 6. Therefore, okay, we already know the angle, so we can form the formula of area. So area equals to A anti, oh sorry, we have 1 over 2 in front, r squared d theta. So area equals to 1 over 2 integration from negative pi over 6 until pi over 6. So r is 4 cos 3 theta squared d theta. Okay, this is for one petal. Okay, this is for one petal. One petal. But in this case, the question did not mention about the number of petals. So we assume this question want all petals. So we have to multiply by 3. Okay, so for 3 petals, the area equals to 3 times 1 over 2, negative pi over 6 until pi over 6, 4 cos 3 theta squared d theta. Okay. However, guys, alternatively, or let's say we consider only half of the petal. Okay, for example, let's say I just consider this, the half, only half. So I will consider angle start from 0. Okay, why? Because a substitute theta equals to 0 is much easier compared to substitute theta equals to negative pi over 6. Okay, so that's why sometimes we can consider half of the petal. So we need to multiply by 2 lah. Okay, or alternatively, I will write here A equals to 3 times half times 2. Why times 2? Because I consider half. So the angle start from 0 until pi over 6. 4 cos 3 theta squared d theta. Okay, so both of this will give you the same answer. Don't worry. Okay, both will give you the same answer. Either you consider the whole petal or you consider half petal, and then you have to multiply by 2 lah, of course. Okay, because of this, we need to multiply by 2 because the angle start from 0. Okay, so let us proceed this, guys. So we can cancel this and this. So I can proceed this. So 3 times 0 until pi over 6. 4 squared is 16. Cos squared. So cos squared 3 theta d theta. Okay, so now 16 times 3, we get 48. 0 until pi over 6. Cos squared 3 theta d theta. Okay, we will use the double angle formula. All right, double angle formula. We have, okay, as we know, if we have cos squared theta, we can use this in order for us to integrate. So 1 plus cos 2 theta. Therefore, in this case, we have cos squared 3 theta. Okay, cos squared 3 theta. Therefore, it becomes 1 plus cos 3 times 2. Okay, why? Because we have theta, it multiplied by 2 becomes 2 theta. Therefore, in this case, since we have 3 theta, so multiply by 2, we have 6 theta. Okay, so we are going to substitute this inside of our integration. So it becomes 48 0 until pi over 6. So we have a substitute 1 over 2, 1 plus cos 6 theta, d theta. Okay, so half multiplied by 48 should be 24, 0 until pi over 6, 1 plus cos 6 theta, d theta. So now 24, integrate 1 with respect to theta, we will have theta. Okay, we have integrate 1 with respect to theta, we get theta. And then integrate cos, we will get what? Positive or negative sign?
Positive.
Positive, very good. Okay, so we will have positive sign, 6 theta. So where should we bring this 6? We should bring 6 to the
Bottom.
lower part here, right? Okay, so we have, okay, very good. So we have over 6. And then substitute 0 and pi over 6. So we will get 24. Okay, substitute pi over 6 plus sine 6 times pi over 6 over 6. And then minus 0. Okay, that's why I prefer substitute zeros because it's much easier. So it becomes 0. Okay. So now this 6 and 6 can be cancelled. So sine pi is actually 0 lah. Okay, so we have pi over 6. So 24 multiplied by pi over 6, we get 4 pi. Okay, this is the answer. All right. Sorry. So next question. I believe that for question number 2 is much easier because it's already state the quadrant, second and fourth quadrant. And as we know, quadrant should be like this. We have first, second, third, and fourth quadrant, isn't it? And then the angle should be, of course, you have to take note, the angle here should be 0, up here should be pi over 2, theta equals to pi, theta equals to 3 pi over 2. So we just consider the angle accordingly, according to the axis. Okay, so let us do question number 3. Okay, question number 3. We have a combination graph. All right, so which one here? Okay, question number 3. Find the area of the region inside the cardioid. Okay, we have a cardioid and outside the circle. So let us sketch the graph. Okay, let's say we start with circle because circle is much easier. Lukis bulat je. Alright, so we have this x-axis and y-axis, of course. So we have a circle with radius 3. Let's say this is the circle. Okay, now this is 3. Okay, guys. We have this cardioid. This cardioid is symmetric to which axis? We have cos. So which axis? X or Y?
X.
X-axis. Okay, good. X-axis. And then we have plus here. Should be right or left?
Right.
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 Okay, right. Yes, very good. On the right. So we have this. So on the right. Okay, something like this. So here should be 4. Right here is 2. Okay. So now, guys, it said that inside the cardioid, outside circle. Okay, inside cardioid, outside circle. Therefore, the region should be, let us shade the region, should be inside cardioid, outside circle, should be here, right? Okay, did you agree with me?
Yes.
Okay, so now the angle should be the intersecting angle. So intersect between the two lines, between the two graphs should be here. Okay, and then here, they intersect. So we need to find what's the angle here and here. Okay. So in order to find the intersecting angle, find the intersecting angle. Okay, for the case of combination, what you should do is you have to equate both radius. So equate R1 with R2. Okay, the first radius belongs to the cardioid. So R1 is 2 plus 2 cos theta. Equate this with the second, R is a circle, R equals to 3. Okay, so equals to 3. So we have 2 cos theta equals to 1, and then cos theta should be 1 over 2. Okay, now use your calculator, shift cos half equals to what? How many degrees?
Pi
You
over
will
3.
have, yes, pi over 3 or 60 degrees, right? So we have pi over 3. Okay, since this graph is symmetric about x-axis, thus we know that up here is pi over 3. So of course down here should be negative pi over 3. Okay, so let us proceed with the formula. 1 over 2, start from negative pi over 3 until pi over 3. And then we have what? Circle minus cardioid or cardioid minus circle?
Cardioid minus circle.
Okay, good. Cardioid minus circle, right? So let's say this is the line of cardioid. Okay, and then the yellow color is the line of circle. So that's why cardioid minus circle. Okay, so we have cardioid 2 plus 2 cos theta squared minus 3 squared circle. So d theta. Or again, in this question, you also can have half region. So A equals to 1 over 2 times 2. So when we consider half, because this graph is symmetric, so we consider theta start from 0. Okay, so I just consider half of this. Let's say this region. And then I have to multiply by 2, of course, right? So, or alternatively, I should multiply by 2 here. So we consider from 0 until pi over 3. Okay. And then we have the same formula, of course. So cardioid minus circle. It's up to you guys. Either you want to calculate full region or half region. Both will give you the same answer. But for the half region, you have to multiply by 2 lah, of course. Did you understand this, guys? Did you understand?
Yes.
Yes.
Okay.
Yes, Madam.
All right. So now we can cancel this. Let us proceed. So equals to 0 until pi over 3 plus 2 cos theta. All right. First of all, slowly. First of all, 2 squared. So we have 4. And then after that, we need to put this, since this is plus, so plus. Okay, multiply everything. 2 times 2 times 2 cos theta. So we have 8. Okay, 8 cos theta. And then after that, plus 2 cos theta squared. So we have 4 cos squared theta. All right, so done already for the first term. And then minus 3 squared is 9 d theta. Okay, so now we can solve this. Negative minus 9. So we have negative 5. So 0 until pi over 3, we have negative 5 plus 4. All right, guys, now this one, we need to substitute with the double angle formula. So cos squared theta, you have to substitute this with 1 over 2, 1 plus cos 2 theta. Okay, so substitute here, multiply by 1 over 2, 1 plus cos 2 theta, d theta. Okay, so let's expand this. We have 0, pi over 3, negative 5 plus 8 cos theta plus 2 plus 2 cos 2 theta d theta. So now we can solve this. Negative 5 plus 2 becomes negative 3. Okay, so 0 until pi over 3, negative 3 plus 8 cos theta plus 2 cos 2 theta. Okay, so now integrate negative 3, we can have negative theta. Integrate 8 cos theta becomes 8 sine theta. Integrate 2 cos 2 theta. So becomes 2 sine 2 theta over 2. Okay. So substitute pi over 3 and 0. Of course, this one you can cancel. Alright. So let us substitute the value. We have negative 3 times pi over 3. And plus sine 2 pi over 3 minus 0. So of course lah, everything is 0. Then we will have, this can be cancelled. This one should be square root 3 over 2 pi over 3, also positive square root 3 over 2. So we're gonna have negative pi. Okay, so 8 plus 1 becomes 9. Okay, so this is the answer. Alright, understand guys? Did you understand this?
Yes, madam.
Alright, so next. Okay, let's say question number 4A. Actually guys, for question number 4, you have to do it separately. This is not a combination type of question. But I believe in final exam, there will be a combination type of question. Just like question number 5. It's okay, later we will do the question number 5. But first I would like to explain about question number, let's say 4A lah. Okay, 4A, not really do this, just to give you idea how to solve this. So question number 4. Let's say we look at the first radius, r equals to 2. So it's very simple, guys. Of course, we have radius 2. So this is the radius. And then we just consider all of this. So of course, the area should be 2, not 2, half multiplied by 0 until 2 pi. So 2 squared d theta lah, of course. And then we have r equals to negative 3, also a circle. Okay, just the same graph, but now we have radius 3. Okay, so 3 here. Again, we consider all. And then we have area equals to 1 over 2, 0 until 2 pi. Negative 3 should be squared d theta. Okay, so let's take a look at r equals to 4 sine theta. Graph sign should be symmetric to which axis?
Y-axis.
Yes, y-axis. Good, y-axis. So we have x, we have y. So let's say this is the graph, okay? And then this is equivalent to 4. So we have this. Okay, you need to be careful, guys. For for the previous two questions, we consider angle from 0 until 2 pi because the radius is complete circle like this for all region, for all quadrant. I mean all quadrant. Okay, first quadrant they cover, second quadrant ada, third quadrant ada, fourth quadrant pun ada. Okay, but in this case, for the graph of 4 sine theta, we just consider from first quadrant until the second quadrant. So the angle would be what? starting theta equals to 0 until what? What's the angle, guys?
Pi, madam.
Pi, yes. So 0 until pi. So you have to look at the location of the region. So not necessarily always 0 until 2 pi lah. So you kena tengok position dia dekat mana region. Shaded region tu dekat mana. So for this case, we have 0 until pi. So 4 sine theta d theta squared. Okay, so let us solve this question. So we have 1 over 2, 0 until pi, 4 is 16 sine squared theta d theta. So 16 times half should be 8. Okay guys, so now sine squared, you have to substitute with the double angle for sine squared. Dia berbeza it's different with cos squared. Kalau sine squared theta dia jadi apa guys? 1 over 2, 1 plus or minus?
Minus.
Minus.
Yes, good. Minus cos 2 theta. Dia cos juga tapi dia minus. Itu beza dia. Kalau sin squared dia adalah minus cos 2 theta. Okay, so let us proceed. 0 until pi. So we have 1 over 2 times 1 minus cos 2 theta d theta. So we have 4. Okay, 0 until pi, 1 minus cos 2 theta. So we have theta minus, okay, the integrate negative cos, we will get negative sine 2 theta over 2. So we will have 0 until pi. Therefore, we have 4 pi minus sine 2 pi. Sine 2 pi over 2 minus 0, minus sine 0 also 0. Okay, so sine 2 pi also 0. So the answer is 4 pi. Guys, in final exam, actually you can double check your answer. You can double check your answer by using the formula. If you know that the formula of circle, formula area, because during my lecture yesterday, one student asked me whether she can use the formula of area for circle. Formula of area for circle should be like this, right? Pi r squared. So in this case, she said that this is radius 2. Okay, radius here is 2. So yes, of course, we can double check. So pi equals to 2 squared, so 4 pi. See, the same answer, isn't it? We have the same value, so 4 pi. So you can use this just to double check your answer, whether your answer is correct or wrong. Okay, but you cannot put this formula, you cannot answer this formula in final exam because we will ask you to use the single integration formula. So you have to do integration. Get my point, guys? Understand what I mean?
Yes.
Okay,
Yes.
good. Right, so now, okay, I think the rest of question number 4 is quite easy. All right, so let us straightforward to question number 5. Question 5. We have, okay, circle and cardioid. All right, let us sketch the region. Circle and cardioid. Okay, in this case, if you notice here, the value is the same. 2 and 2. Okay, so this graph would be nice. It will be intersect on the axis. Okay, now we have this. This is the circle. Okay, we have 2 here. And then now, how about this? 2 minus cos theta. So it should be on the right or left?
Left.
Left.
Left. Okay, left. Very good. So we have this. You have to be careful, guys. Right now, the values is the same. So it will be intersect here at 2. And also the lower part here, negative 2. Okay. Something like this. So here should be negative 4 and here is negative 2. Okay. So let us, okay, let me, the yellow color is the cardioid. The green color is the circle. Okay, now the question asks you to find the area of the region outside the cardioid but inside the circle in the first quadrant. Okay, in the first quadrant, outside cardioid but inside the circle in the first quadrant. Okay, outside cardioid, inside circle. So it should be here, isn't it? Okay, di luar cardioid. Cardioid tu warna yellow tu. Okay, but inside circle, circle the green color in the first quadrant. So this is the region. Okay, now guys, since this from the figure, okay, from the region itself, we can see directly that the intersecting angle is located on the axis. So automatically we know that this angle equals to 0 and this angle equals to pi over 2. Okay, this question is different from the previous question. Okay, kalau tengok previous question yang ni, dia punya intersecting angle tu guys, intersecting dia tak betul-betul intersect pada part C, pada axis. That's why we need to find the intersecting angle by using this formula. Okay. However, for question number 5, the intersecting angle is located exactly on the axis. So that's why no need for you to find the intersecting angle, but just look at the region and directly you know the angle from the graph. Understand, guys? Understand what I mean? Okay, kita dah tahu daripada graph dah. Tak payah kira pun. Kalau tadi kena kira kan, kena samakan R1 dengan R2. But now no need for you to calculate. No need for you to calculate. You just look at your graph and you can, you will know the angle, the point, the angle of intersection. Okay, so question number A. Area equals to 1 over 2, integration from 0 until pi. Okay, now, pi over 2, sorry. Okay, now, which one? Cardioid minus circle or circle minus cardioid?
Circle minus cardioid.
Okay, good. Circle minus cardioid. Wait a minute. Okay, sorry, I need to reply the WhatsApp. Okay, about work. Okay, cardioid, circle minus cardioid. Yes, well done. Circle minus cardioid. So we have 2 squared minus cardioid. So cardioid is 2 minus 2 cos theta squared d theta. Alright, so we can proceed now. So 1 over 2, 0 until pi over 2, 4 minus. Okay, let us expand this. 4, okay, becomes minus lah sebab ni minus So we have 2 times 2 times 2 cos theta, 8 cos theta. And then the last one should be plus because negative 2 cos theta squared. So becomes plus 4 cos squared theta, like this. Okay, so now cos squared is equivalent to 1 over 2, 1 plus or minus, guys?
Plus.
Plus, yes, good. So cos 2 theta. Letak kat situ. So of course 4 minus 4 becomes 0 lah. So we have 1 over 2. 0 until pi over 2. We have negative 8 cos theta, so becomes positive 8 cos theta. And then we have negative times plus, it becomes negative. So negative 1 over 2. And then negative lagi lah, sebab the positive and negative 1 over 2 cos 2 theta. Oh, sorry, multiply by 4. Wait a minute, I have to erase this. Minus 4. Buat satu lah. 1 over 2, 1 plus cos 2 theta. Like this, d theta. Okay, so 4 times half. 8 cos theta minus, jadi 2. And then minus 2 cos 2 theta, isn't it? Kalau saya ada tersilap, bagi tahu Takut saya terlepas pandang. Okay, so now let us proceed with the integration. Okay, 8 cos theta becomes 8 sin theta, of course. Minus 2 theta minus 2 sin 2 theta over 2. Substitute 0 and pi over 2. So we have 1 over 2. 8 sin theta. So 8 sin pi over 2 minus 2 times pi over 2 minus, okay, this one can be cancelled. Sin 2 times pi over 2, so sin pi lah. Minus, of course, everything is 0. Okay, so sin pi over 2 is 1. Sin pi is 0. So we will have 1 over 2, you darabkan dengan 8 minus pi. So the answer is 4 minus pi over 2. 4 minus pi over 2, betul ke? Question 5A. 5A, yes. Okay. 4 minus pi over 2. Alright. So next question B. Again, sketch and find the area of the region outside the circle but inside the cardioid. Circle inside cardioid. Again, you have to sketch. Question B. Yep, it's outside circle inside cardioid. Outside circle inside cardioid. So yes, let us sketch the region again. I will use the red color for the circle. The green color for the cardioid. Okay, of course we know here should be 2. Lower here 2. Right here is negative 4. Right here is negative 2. Here is 2. X and Y. Okay, outside circle but inside the cardioid. So where is the position? Right or left?
Left.
Left. Okay, well done. Dia ada bagi tahu quadrant ke? Tak ada. So whole part lah. This region. Okay, now the angle. The angle should be here. So theta equals to pi over 2. And then bawah ni kan, theta equals to 3 pi over 2. Okay, this is the angle. Angle here and here. Okay, so we can proceed with the calculation. Area 1 over 2 times from pi over 2. Ingat limit bawah, the lower limit must be smaller than the upper limit. 3 pi over 2. Okay guys, now which one? Circle minus cardioid or cardioid minus circle?
Cardioid minus circle.
Okay, good. Cardioid minus circle. So we have 2 minus 2 cos theta minus 2 squared. Macam ni, d theta. Okay, so let us proceed with the calculation. So 1/2, pi/2, 3 pi/2. Let us expand this again. So of course we can cancel this 4 and this 4. Again, you have to substitute. This is 1/2, 1 plus cos 2 theta. Okay, so we will have macam tu. D theta. So now let us integrate this. Substitute pi/2 until 3 pi/2. So yes, we can cancel this. Negative 8 sine 3 pi/2 plus 2 times 3 pi/2 sine 3 pi minus sine 2 times pi/2 is sine pi. Close the bracket. Okay, so sine 3 pi/2 is negative 1. This one can be cancelled. Sine 3 pi is 0. Sine pi/2 is 1. This one can cancel. Sine pi is 0. So we will have negative 8 times negative 1. So becomes 8 plus 3 pi 0. And then minus negative 8. Negative 8, okay. And then plus pi. Alright, like this. So we will have 1/2, 16, apa ni, 3 pi minus pi, so jadi 2 pi. So divides by half, 8 plus pi. Isn't it? What's the answer? 8 plus pi, yes, okay. Ni. Do you understand, guys? Do you understand? Question B.
Yes.
Yes, madam.
Cuba jawab soalan tu saya tanya. Saya tak kisah you nak makan breakfast ke apa sambil kelas ni. It's okay, tak apa. I don't mind. But just respond. Because I don't know you whether you understand or not. Okay, so question C. Sketch and find the region inside both the circle and cardioid. Inside both pula. Jom kita sketch. Inside both. So we have this. X and Y. So let's say again I use red color for the circle. And then the green color for the cardioid. Here should be 2 lah. 2, negative 2, negative 4, negative 2 and 2. Okay, inside both. Guys, inside both. Apa ni? Macam mana ni? Inside both circle and cardioid. Where is the region? Dalam kedua-duanya sekali. Macam tu.
Semua.
Semua, no, cannot. In the third quadrant. Sorry, saya tertinggal kan. Soalan dia third apa ni? Third quadrant. Third quadrant. Dia maksudnya di kawasan yang bersilang tau. Sebab dia kata it must be intersect lah. Sebab inside both. Dia macam macam ni. Macam tu. Bersilang Dia inside both. So should be kalau kedua-duanya, right here, right?
Circle.
Quadrant, it should be here, isn't it? Can we
Yes.
consider this area? Can we consider the yellow color?
No.
No.
No, cannot. Okay, good, very good. Means that you understand this. Cannot, we cannot consider the yellow color because the question asks you to find inside both circle and cardioid. So right now, luckily in this case, since this is the only the region, therefore we just consider what? We just consider the line of circle, isn't it? So our
Yes.
integration would becomes much easier, 1/2. Okay, the angle should be from here, theta equals to pi until theta equals to 3 pi over 2. So of course we have here pi, 3 pi over 2. Okay, now the r that involved in this region is what?
2.
Yes, 2. Okay, 2 because only one line. Only the line for circle. So we just consider 2. That's it, d theta. Okay, so let us proceed. 1/2 becomes integration of 4 d theta. So we will have 4 times half should be 2. So theta substitute 3 pi over 2 minus pi. Three pi over 2 minus pi should be pi over 2 lah kan? So it becomes pi. Okay, what's the answer? 2 ke pi? Tu lah. C equals to pi. Alright. So, finish already subtopic 4.1. Let us proceed to 4.2. Double integral. Integrals over rectangular region. Okay, over rectangular region. I believe you already watched my video in YouTube. So basically, double integration should be, we have double integral with over the region R. R is the rectangular, rectangular. Rectangular means all, okay. Rectangular region means all limits are constants. Okay, rectangular means all limits are constants. So the formula should be fxy dA. Okay, of course this dA can be either dy dx or dx dy. It's up to you. Okay, for the case of rectangular, you can just switch the position, the order of integration. Never mind, tak ada issue. So you boleh tukar-tukar je. Sebab apa? Because of rectangular region, because all the limits are constant. You can just switch dy dx into dx dy. However, for the case of non-rectangular region, in the next subtopic next week, subtopic 4.3, you have to be careful. Okay, for the case of non-rectangular region, you cannot just switch the position. Okay, sebab dia melibatkan function. However, in this case, semua limit adalah constant, adalah nombor sahaja. So you can just switch the position. Never mind, tak ada masalah, tak ada issue. Okay, so now let us proceed to exercise 4.2. Okay, exercise 4.2. Let's take a look at question. Okay, let us do question number 1, the basic one, so that you can understand the concept. Okay, copy first this. Okay, this question also asks you to sketch, isn't it? You have to sketch the region of integration and evaluate the integral. Okay, sketch the region and evaluate the integral. So let us sketch the region. We know that this is the rectangular region. Okay, first of all, you have to understand this. The inner integration is with respect to y. So the limit of y should be the inner part, 0 until 3. Okay, so y is from 0 until 3. And then the outer limit, the outer integration is dx. Therefore, the limit for x is belongs to 0 and 1. So guys, basically, bila kita nak lukis region, okay, region kita tengok pada limit. This is to sketch the region R. Okay, so right now x is from 0 until 1. So let us sketch the region R. Of course, region R is a rectangular region. We have x-axis and y-axis. So y from 0 until 3, and then x from 0 until 1. So therefore, this is the region. Okay, this is the region, rectangular. Kan tu nama dia rectangular tu, petak. So let us proceed with the integration. 0, 1, 0, 3 to x plus 1 dy dx. Okay, now guys, you have to bear in mind when you want to integrate with respect to y, x becomes constant. Okay, the same concept as in chapter 3, partial derivative. If we want to differentiate with respect to y variable, therefore x constant. The same thing happen here when we want to integrate with respect to y adalah variable, however, x becomes constant. Okay, x becomes constant. So what you should do now is 0 until 1. Okay, integrate 2x with respect to y. 2x just a constant, so copy it down, and then we have to multiply with y. Okay, plus integrate 1 with respect to y is y. Substitute y equals to 0 and y equals to 3 dx. Did you understand this step? Guys? Understand?
Yes.
Ni basic ni. Saya memang explain question number 1 sebab dia paling basic. Okay. So now 0, 1 substitute y. Kenapa saya tulis? Yesterday one student asked me, Madam, do we need to write this? I write this so that student do not confuse to nak substitute kat mana. Okay, that's why saya tulis. Kalau you tak tulis pun tak apa. Kalau you dah expert tak payah tulis. Tapi kalau you still got confused, you kena tulis lah supaya you tahu, oh ganti dekat y, jangan ganti dekat x. Okay. So now 2xy, y equals to 3. So 2xy, so 6x plus 3 minus substitute 0 plus 0 dx. So we just need to integrate this lah. 6x plus 3 dx. So we will have 6x squared over 2 becomes 3x squared plus 3x. So substitute 0 and 1. So 3 plus 3 equals to 6. That's the answer. Okay, next. Let us do question number 4. Okay. Alright, again, if you want to calculate this, let us sketch the region first. Right. So sketch the region. Of course, we know that the limit of x is from 0 until pi over 2. So x from 0 until pi over 2, and then y is from pi over 2 until pi. Okay, pi over 2 until pi. So right now, let us sketch the region R. So x from 0 until pi over 2. Pi over 2 is also a value, a constant. And then y from pi over 2 until pi. So we have this region. So shaded region dia dekat sini lah. Alright, so this is the region R. Okay, now let us solve this. Pi over 2 until pi. Okay. Listen here carefully, guys. Now we want to integrate with respect to x. Okay, integrate with respect to x. So x the variable, therefore the whole thing here, y, becomes just a constant. Constant. Sebab kita integrate terhadap x. So yang term kedua tu, the whole thing tu you anggap dia macam satu nombor, macam nombor 10. You can assume macam tu. Okay, so let us do one by one here now. Integrate to cos 2x with respect to x. Okay, terhadap x. Integrate, so integrate cos, of course we will get sine, isn't it? So 2 sine 2x. And then we should bring this to the lower part here, like that. So settle the first term. Now the second term, now integrate 3 sine 3y with respect to x, terhadap x. Tadi saya dah pesan 3 sin 3y ni jadi constant. So dia jadi apa guys? Bila integrate constant.
3x sine 3y.
Yes, you have to multiply the constant with x. So it becomes 3 sin 3y tu you just salin balik, darab dengan x. So dia akan jadi minus 3x sin 3y, like this. Okay, and then now kita substitute apa ni? X ke y? Nilai apa? Nilai x ke y yang kita kena substitute sekarang ni, limit dia?
X.
X, yes. X equals to 0 and x equals to pi over 2 dy. Okay, now yang ni kita boleh cancel lah. Just like that. Okay. So, we will have from pi over 2 until pi sine 2 times pi over 2. Like this. So, we have minus 3 pi over 2 sine 3 pi over 2 minus substitute 0, sine 0 is 0, 3 times 0 also 0, dy. So sine 2 dengan 2 sine pi is also 0. So sine 3 pi over 2 is negative. Sorry. No need for me to substitute here, isn't it? Because saya pun dah confused dah. Ni. Sine 3y. Ni just maintain sebab kita ganti dekat x je kan. So sine 3 pi over 2 sine 3y. Just maintain lah. Okay, sebab because kita just substitute pada x sahaja. Kita ganti kat sini je. So 3 pi over 2. Ni, x. So sin 3y just maintain lah sin 3y. Okay. Saya pesan saya pun tersilap. Sorry guys. Okay, so sin pi is 0. So we have negative 3 pi over 2 sin 3y. So kita akan ada pi over 2 until pi negative 3 pi over 2 sin 3y with respect to y. So we just integrate. 3 pi over 2 just a constant. So negative 3 pi over 2. Okay, integrate sine. We will get what? Positive or negative cos? Integrate sine.
Negative cos.
Yes, good. Negative cos. So negative cos 3y over 3. Okay, substitute ni. 3 ni bawa ke bawah. So jadi macam ni lah. So next, substitute the values pi over 2 until pi. So we will have, okay, now this 3 can be cancelled. This 3 can be cancelled. Negative also can be cancelled, becomes positive. So dia akan jadi pi over 2. You substitute cos 3 pi minus cos 3 pi over 2, just like this. And then we know that cos 3 pi is negative 1, cos 3 pi over 2 is 0. So therefore, the values is negative pi over 2. Okay, that's it. Alright, so next question. Let us do question number 5. Ada lon ni. Okay, question number 5. So now, if you sketch the region y equals to from 0 until ln 3, and then x from 0 until ln 2. Okay, don't get panicked with the ln, it's still a constant. So you can just sketch the region. Y equals to 0 and then y equals to ln 3. Okay, this is y. And then x from 0 until ln 2. So we have this and this. Therefore, this is the region. Okay, region, all right. So let us calculate this. 0 until ln 2, 0 ln 3. Okay, I would like to separate this. So it becomes exponent 2x multiply with exponent y. dy dx. So now since we are integrating y, okay, exponent y terhadap y, therefore the whole thing here becomes a constant, just a constant. Okay. So we will have 0 until ln 2. Integrate exponent y, of course, becomes exponent y lah. So exponent x can be taken out. So exponent y, substitute 0 and ln 3 dx. So it becomes 0 until ln 2, exponent 2x, exponent ln 3 minus exponent 0 dx. Okay, exponent ln 3 jadi apa ni guys?
3.
Yes, jadi 3. Okay, well done. Exponent 0 jadi
1.
1. Okay, so we will have 0 until ln 2, exponent 2x. So 3 minus 1 becomes 2 lah. Okay, so we have 2, 0 until ln 2, exponent 2x dx. So integrate exponent 2x, we will get exponent 2x over 2. Okay, so substitute 0 and ln 2. So this one, 2 and this 2 can be cancelled. And then we have exponent 2 ln 2 minus exponent 0. Okay, so exponent 2 ln 2 is actually exponent ln 2 squared, isn't it? And then minus exponent 0 is 1. So exponent ln 4 should be equals to 4 minus 1. So we have 3. Okay, so the answer is 3. Understand, guys? Any question?
Yes.
Okay, good, well done. So next, question, where is? Which question, guys, you want me to solve? Just tell me, which question? You nak saya solve lagi? Which question? You all ni macam mana ni? Question number?
10.
Number 10, yes. Jom kita buat soalan number 10. Question number 7, 8, 9, can you answer it? Boleh? You all tak buat lagi sebenarnya ni. Question number 10. Dah boleh buat dah. Okay, good. Very good. So question number 10 Okay, so now, since this is rectangular region, so it's up to you. You can use dy dx or dx dy. Okay, sekarang saya tanya, you all nak dx dy ke dy dx? Saya jawab ikut apa yang you nak. You all nak apa? dy dx ke dx dy?
dy dx.
dy dx. Okay, jom kita buat soalan ni dy dx. Alright, so xy over square root of x squared plus y squared plus 3 dy dx. Okay, so since you choose dy dx, inner limit daripada mana ke mana ni? Yang ni, inner limit ni, daripada mana ke mana?
0
From
to 2.
0 until 2, yes. And then x from 0 until 1. Okay, so let us do this slowly. Okay, now guys, we want to differentiate, integrate with respect to y. So what happened to x? Apa jadi pada x bila integrate terhadap y?
Constant.
Constant, yes. So we can just take out the constant. So 0 until 1. And then we have, we can just consider this. Okay. This one just a constant. Okay, so we just consider y tu je lah. Okay, right now since we have this form, okay, square root ni, you need to make a substitution. Okay, we use a substitution. Alright, let U equals to x squared plus y squared plus 3. Okay, ni you kena salin ni guys. Salin soalan ni. Okay, now we differentiate U with respect to y. So you kena anggap x tu constant. X ni sama level dengan 3. Dia just a number. So we just consider y ni. So differentiate y squared, we will get 2y dy. Therefore, dy akan jadi du over 2y. Okay, so settle with that substitution. Now the limit, I want to substitute the limit also. Okay, so when y equals to 2, what happened to the u? U equals to x squared plus 2 squared plus 3 because saya substitute y equals to 2 ni dekat y ni. Ni y. Y kan tadi y squared tu, so 2 squared. So it becomes u equals to x squared plus 4 plus 3, so plus 7. So settle. Now this the lower limit. Saya gantikan lower limit pula. When y equals to 0, we will have u equals to x plus 0 plus 3. So we will have limit u akan jadi x squared plus 3. Okay, now we have to substitute. Okay, ni saya padam balik. We have to substitute into the integration. Okay, 0 until 1 ni maintain. Okay, now substitute limit 0 jadi x squared plus 3. Okay, limit 2 atas tu dia jadi x squared plus 7. Alright, and then the terms atas ni xy ni maintain square over square root of u like this. Okay, because this is u kan. Bawah ni yang color yellow ni becomes u. So square root u lah. Okay, now dy yang color green ni dy. Dy dia jadi du over 2y like that. So dy dia jadi du over 2y. So settle and then belakang ds maintain lah. X tak ada effect lagi. Okay, now this y can be cancelled. Okay, can be cancelled. So if we rewrite this again, 0 until 1, x squared plus 3, x squared plus 7. So x multiply by u. U tu per kan, jadi u to the power of negative half like this. Du dx. Understand this step? Saya bawa naik u tu. So jadi kuasa negative half lah. Okay, so next 0 until 1, x squared. Oh sorry, no more. Okay, x tu bawa keluar because it's just a constant. This x just a constant, you bawa keluar siap-siap. So integrate u to the power of negative half plus 1. So plus 1 it becomes u to the power of half, isn't it? Over half lah. Integrate u negative half tu. Okay, so substitute x squared plus 3, x squared plus 7 dx. Okay, so negative half ni, negative half pula. Yang half ni kat bawah ni bila naik dia jadi 2 kan? Isn't it? Dia jadi 2. Okay, saya tertinggal ni tadi 1 over 2 ni. 1 over 2, so 1 over 2. So 1 over 2, macam tu. Okay, saya tertinggal tadi. So dia akan jadi 0, 1, 1 over 2x and then multiply by 2, u to the power of half ni, substitute x squared plus 3, x squared plus 7 dx. Okay, so these 2 dengan 2 ni can be cancelled. Alright, so it becomes zero until 1 x, you substitute lah. Substitute dekat u ni. So dia akan jadi square root of, sebab u punca kuasa kan. So x squared plus 7. Okay guys, sekejap saya buat step by step. Kan tak faham pula. Macam ni. X squared plus 7 half minus x squared plus 3 half. Macam tu. dx. So you akan dapat darab masuk dalam 0, 1 x square root of x squared plus 7 minus darab masuk x square root of x squared plus 3. Macam tu. Okay. Ni, saya darab yang ni. Lepas tu saya darab kat sini. So dapatlah macam ni. Okay guys. Now, what happened here? You have two integration. So let's say I declare this as part A and this is part B. So you have to solve one by one. Now let us solve part A. Integration from 0 until 1 x square root of x squared plus 7 dx. So what you should do now? Again, we need to use substitution. So we let u equals to x squared plus 7. So differentiate u, we will get 2x dx. And then when, okay, substitute the limit. When x equals to 0, kita ada u sama dengan 0 squared plus 7. So u equals to 7. Okay, and then when x equals to 1, ni, saya gantikan ni, limit ni. Okay, when x equals to 1, u equals to 1 squared plus 7. So equals to 8. Alright, so now let us substitute into this integration. We have integration for 0 is 7 until 1. 1 is 8. So x substitute u square root dx is du over 2x. Ni dx ni adalah du over 2x lah. Okay. So we can cancel this happily. You cancel je. Alright. So it becomes 7 until 8 u to the power of half du. So integrate ni you dapat apa ni? Kuasa half jadi u to the power of 3 over 2 over
du over 2.
2 meter.
to the power of 3 over 2, substitute. You will have 1 over 2 tertinggal lagi. ni, saya selalu tertinggal ni. Okay, thank you very 1 over 2. Macam tu. So 1 over 2, this one can be cancelled. So 1 over 3 lah. So jadi 1 over 3, substitute into u. We will have 8. So baru settle part A. Jom kira part B pula. Ni baru part A. Alright, solve part B. Integration from 0 until 1 x squared plus 3 dx. So now kita nak let u equals to what dalam kes ni?
X squared plus 3.
X squared plus 3. So now differentiate u, we have 2x, therefore 2x dx. U over 2x lah. So again, when x equals to 0, we have u 0 squared plus 3, so it becomes 3. And then when x equals to 1, we have u equals to 1 squared plus 3, so it becomes 4. So substitute here the limit from 0, 3, and then x square root of u to the power of dx. dx is du over 2x. So this cancel and cancel. And then we will have 3 until 4, 1 over 2 to the power of half d over 2, u to the power of 3 over 2 over 3 over 2. So saya direct tulis 3 and 4. So it becomes, ini jadi apa ni? So 1 over 3, 4 to the power of 3 over 2 minus 3 to the power of 3 over 2. Okay, now solve A minus B, isn't it? Dia A minus B tadi kan? A minus B. So yang ni A ni tadi is minus minus 1 over 3, 4 to the power of 3 over 2 minus 3 to the power of 3 over 2. Kita boleh kecilkan lagi tak? 8 tak boleh kan? 7 tak boleh. Okay, 4. 4 to the power of 3 over 2. Kalau kita simplify jadi power of 3, so it becomes 8. Isn't it? Kan jadi 8 kan? Punca kuasa 4. Take out 1 over 3, dia jadi 8 to the power of 3 over 2 minus 7 to the power of 3 over 2 minus 8 minus becomes plus. So plus 3 to the power of 3 over panjang ni ha. Is it the answer? Tengok sikit jawapan dia apa. Betul lah ni. Understand guys?
Faham ni.
Can you solve this in your final exam? If this type of question come out in your final exam, boleh jawab?
InsyaAllah.
Banyak
InsyaAllah.
hopefully.
Okay. Alright. Okay, last question before I finish the class. Let us do volume lah Volume. Kita tak buat lagi soalan volume. Okay, so volume, let us do this question. Question number 13. Kalau kita guna double integration, formula volume is like this. Double integration R fxy dA. Of course, ni fxy ni, this is your z actually, function z. Okay, so in this case, this is our z lah. So the volume should be V equals to double integration function z kita 2x squared plus 3xy squared d. Okay, you nak dy dx ke dx dy? Saya follow je ni.
dx dy.
Dx dy. Okay, jom kita buat dx dy. So the inner limit should be from?
Negative 1.
Yes, negative 1 until 2 and then y from 0 until 3. Okay, so let us solve this. 0 until 3. So integrate 2x squared becomes 2x cubed over 3 plus 3. Dia jadi apa ni? X squared over 2. Y squared, just copy it down here because y is just a constant. So just copy sajalah y tu. And then substitute x equals to negative 1, x equals to 2 dy. So we will have 0 until 3. Open this. So we have 2 over 3 times 2 cubed. So 2 cubed plus 3 over 2, 2 squared times y squared minus negative 1. So negative 1 cube jadi negative 2 over 3 lah. Plus negative 1 squared jadi positif. So 3 over 2y squared dy. So 0 until 3. 2 per 3 darab 8 kan. So jadi 16, 16 over 3. Kalau saya salah beritahu Saya takut saya tersilap. And then plus 8 kali 2, 16 per 3. 4 kali 3, 12 per 2. So 6y, isn't it? 6y squared. Minus become plus 2 over 3 minus 3 over 2y squared. Isn't it? So 18, 16 tambah 2. Jadi 18 per 3 should be 6. Guys, you kira sekali jangan main salahnya, saya takut saya salah kira. So should be 6, isn't it? And then plus 6y squared. Oh, sorry, this one should be 6y to the power of betul lah, y squared lah kan? Betul dah. Y squared. Bawah tu pun Y squared. So 6. 6 minus 3 over 2. 12 tolak 3. 92. Kan?
Yes.
1292. Kalau saya salah, boleh tahu So 9y squared over 2 dy. Jom kita integrate. It becomes 6y plus 9. Okay, 9 over 2 y cube over 3. Substitute 0 and 3. So ni jadi 3 over 2. Sorry.
Y square ada.
Betul ke salah ni? So 6y jadi 18 plus 3 over 2 times 27, isn't it? Minus 0 lah, 0 plus 0. Like that. So 18 plus 27 times 3. Should be 81 81 over 2. Cuba you kira guys, saya tak ada calculator ni.
Yes.
So dapat berapa tu?
Yes, madam.
Yes, dapat berapa tu?
58.5.
58.5. Betul ke? Or 58 1 over 2 lah kan? Sekejap tengok jawapan dia berapa Dalam buku question 13. Oh yes. This 58.5. Alright. Okay. So done. Understand guys? Subtopic 4.2. Did you understand?
Yes,
Boleh
madam.
lah.
I will share the notes with you later. Don't worry. Okay.